Today's lesson is problem 3.4, polygons and coordinate grids. Now this is an extremely long video. It's not intended for you to watch all at one time and then do the homework. I want you to work on this as you're watching the video. So have your textbook ready, have your notebook ready, and work through it while you're working on this video, not separately. Let me know if you have any questions. Our goals of the day, GTD, whoop, whoop, are 1, to review, learn how to plot coordinate points. Number 2, to introduce problem 3.4. Number 3, we'll practice some things in problem 3.4. Then your ACE homework will be number 34, parts A and B, and number 35, parts A and B, and that's on page 70. And then, of course, we always want to have fun. So what you need is your textbook, your math graph notebook, your pencil and your pen, and your iPad. Hit pause, make sure you get all the things that you need, and when you're ready, press play and continue with the video. So the first thing we're going to do is have you watch this video from Khan Academy on coordinate plane examples. So it will either teach you or give you a refresher on plotting coordinates on a grid. So watch this video and then continue on to the next page in the slide.
What we're going to do in this video is, through a bunch of examples, familiarize ourselves with the XY coordinate plane. And first we're going to just look at some points that are already plotted and figure out their coordinates. Then we're going to look at some coordinates and figure out where those points are. And then we'll do one more problem. So let's figure out what are the coordinates of these points. So you have this point right here, A. So it's x coordinate. You can see it right there. You just drop down. Where does it intersect the x-axis? X is equal to 5. So it's the point 5, comma, and y is going to be equal to 6. 5, comma, 6. Now this point B here, what's the x-coordinate? It is 5 to the left. 5 to the left of the x-axis. This is negative 5. X-axis, x-coordinate is negative 5. Y-coordinate is, if you just go straight to the right, you're going to hit y is equal to 5. Y is equal to 5. Let me switch colors. C. I think you're getting the hang of this. Let's do the y-coordinate first. The y-coordinate is 3. You see that right there. And then the x-coordinate is negative 2. Negative 2. You always put the x-coordinate first. That's just the convention we use. D. X-coordinate, negative 2. You see that right there. Y-coordinate, negative 2 as well. Let me get another color. E. Let's do the y-coordinate. Well, we'll figure it out first, but you always have to write it second. It's negative 4. You see that right there, the y-coordinate. The x-coordinate is 3. And then finally F. The x-coordinate is 2. And the y-coordinate is negative 6. Hopefully that gives you a sense of at least figuring out the coordinates. Now let's go the other way. Let's start with coordinates and figure out where those points are. So you have this first one. I'll do it lowercase a in parentheses to differentiate it from this uppercase a. So it's at 4, comma 2. X is equal to 4. Y is equal to 2. X is equal to 4. Y is equal to 2. So that's that point right there. Let's do the next one. Let me do it in a color that you'll be able to read. B. X is equal to negative 3. X is equal to negative 3. Y is equal to 5.5. So you go all the way up to 5.5. Right? Y is equal to 5.5. So that is the point lowercase b with parentheses around it. Then C. 4, negative 4. X is equal to 4. Y is equal to negative 4. Right over there. And then one last one. I'll do it in orange. D. X is negative 2. Y is negative 3. X is negative 2. Y is negative 3. Right there. That's the D with parentheses. And you could have gone the other way. You could have said, hey, y is equal to negative 3. X is equal to negative 2. So you could go to the left and down, or you could go down and to the left, and you're still going to get to the same point. So hopefully that gives you a good sense of how to figure out coordinates, or if you're given coordinates, how to figure out where to plot something on the xy coordinate plane. Now let's do a slightly more involved problem. So it says the following 3 points are 3 vertices of square ABCD. Plot them on a graph, then determine what the coordinates of the 4th point D would be. All right, let's plot these on a graph as they tell us to do. All right, that'll be my y-axis. That's my y-axis, the vertical axis. That'll be my x-axis. And let me mark it. So that's x equals 1, 2, 3, 4. This is x is equal to negative 1, negative 2, negative 3, negative 4. That's y is equal to 1, 2, 3, 4. This is y is equal to negative 1, negative 2, negative 3, negative 4. I could write that. That's y equals 4. That's y equals negative 4. X is equal to 4. X is equal to negative 4. And let's see, let's plot these points. So first we have the point A is equal to negative 4, negative 4. So we go x is negative 4, and then y is negative 4. So we drop down 4 right there. And that is our point A, negative 4, negative 4. And just to familiarize yourself with a labeling scheme that you may or may not have seen before, is that people label these sections of the coordinate plane. They call this the first quadrant. They call this the second quadrant. They call this the third quadrant. And they call this the fourth quadrant. And these are just the Roman numerals for 1, 2, 3, and 4. So this point is in the third quadrant. When we looked up at this stuff over here, these points are in the fourth quadrant. These are in the third, second, first. Just an interesting thing to know. Sometimes someone might ask you, what quadrant is that point in? And you just say, oh, okay, I see. If they're both negative, they're going to be in the third quadrant. If just the y is negative, but the x is positive, you're going to be in the fourth. If they're both positive, you're in the first. If y is positive, but x is negative, you're in the second. And we'll talk a little bit about that as we plot these points. So point B, x is positive. It's 1, 2, 3. And y is negative 4. So we drop down here into the fourth quadrant. That is the point B. It's 3, negative 4. So we can already see the bottom of our rectangle that they're talking about right there. And notice, both of these have the exact same y. They're both at the same level below the x-axis. And then what's the next point? Point C is 3, 3. So 3, 3. It's in the first quadrant. Both of its coordinates are positive. 3, 3. Both x and y are positive. And notice, it's on the same vertical as B. It has the same x value. They both have an x value of 3. So it's right above it. Right above it. Now we have to figure out the last point here. Well, the point is going to have to be on the same vertical as this point. It's going to have to be on the same vertical as this point, which means it's going to have the same x value as this point. So the x value is going to be negative 4. And then it's going to have to be on the same horizontal as this point. It's going to have to be on the same horizontal as that point. So it's going to have the same y value. It's at the same height above the x-axis. So it's going to have to be 3. So that is our point D. Notice it's at negative 4, right above A, and it's at y is equal to 3, right to the left of point C. And we are done.
Now that you've watched the video, I want you to open up your textbook to page 60 and 61, 3.4, Polygons on Coordinate Grids. Read the first part where it starts with "you can design," and then look at the polygon. We're going to together review what the coordinates of the vertices B, C, D, and E are. So when you look at this shape, and we look at vertice A, which is right here, the coordinates, because after watching the video, you say the x-axis first, the y-axis second. So the coordinates are, if you count along the x-axis on the bottom, you get 10, and then you go up 7. So you would label this 10, 7. Can you find the coordinates for B, C, D, and E? Pause here and find the answers to these coordinates. When you think they have them, press play. All right, what'd you come up with? So let's look at the coordinates for each vertice. We've got B, which goes over 6 and up 10. So you've got 6, 10. You've got C, goes over 2 and up 7. So you've got 2, 7. You've got D, which goes over 4 and up 3. So you're at 4, 3. And you've got E, which goes over 8 and up 3. Is that what you came up with? So now let's look at the distance between two coordinates, right? What if I said I want to know the distance between D and E? Well, remember, my D is at 4, 3, and my E is at 8, 3, right? So they're both at the same level on the y-axis, but they're at different spots on the x-axis. One is at 8, one is at 4. So simply you could go 8 minus 4 equals 4, or you could count the spaces in between. 1, 2, 3, 4. Now that you've done that, let's move on to problem 3.4 and do some practice. So when you look at problem 3.4, what they want you to do is look at the 4 shapes and provide a description of each shape. So what that is it a parallelogram? Is it a trapezoid? Is it an isosceles triangle? Is it a right triangle? So reviewing those terms, we all remember what a right triangle is, right? It's got a 90-degree angle. An isosceles triangle is where 2 of the sides are equal. We just reviewed parallelograms. Now trapezoid might be something that you're familiar with, or you might need a refresher on, but essentially it's where 2 of the sides are parallel with each other, right? So it's got 4 sides. It's a polygon with 4 sides. 2 of them are parallel with each other. So you're going to put that in the description of the shape. It's one of those 4 things. Then you need to put the coordinates of each of the vertices. So you need to put the coordinates of each one. I'm marking up there. Right? So you're going to have 4 for those shapes. You're going to have 3 for these shapes. So put that in there. And then you're going to look at side lengths where you can. Now, we reviewed that, right? So, but remember with side lengths, you can do it if it's horizontal, or you can do it if it's vertical, right? And I want you to put at least one example of each figure of what that side length is. And then lastly, you're going to put the area. So at this point, I want you to pause the video and work on these 4 shapes and try and fill out this grid as best you can. Once you've finished, press play. Compare what you did to what you see. Did you get the same answers? Now, one thing that we might need to revisit is we never talked about what the area of a trapezoid is or how you find it. Let's look into that closer.
So right here we have a 4-sided figure, or a quadrilateral, where 2 of the sides are parallel to each other. And so this, by definition, is a trapezoid. Trapezoid. And what we want to do is, given the dimensions that they've given us, what is the area of this trapezoid? So let's just think through it. So what would we get if we multiplied this base, this long base 6, times the height 3? So what do we get if we multiply 6 times 3? Well, that would be the area of a rectangle that is 6 units wide and 3 units high. So that would give us the area of a figure that looked like, let me do it in this pink color. The area of a figure that looked like this would be 6 times 3. So it would give us this entire area right over there. Now the trapezoid is clearly less than that, but let's just go with the thought experiment. Now what would happen if we went with 2 times 3? 2 times 3. Well, now we'd be finding the area of a rectangle that has a width of 2 and a height of 3. So you could imagine that being this rectangle right over here. So that is this rectangle
right over here. So that's the 2 times 3 rectangle. Now, it looks like the area of the trapezoid should be in between these two numbers. Maybe it should be exactly halfway in between. Because when you look at the area difference between the two rectangles, and let me color that in. Let me color. So this is the area difference on the left-hand side. And this is the area difference on the right-hand side. If we focus on the trapezoid, you see that it reclaims, if we start with the yellow, the smaller rectangle, it reclaims half of the area, half of the difference between the smaller rectangle and the larger one on the left-hand side. It gets exactly half of it on the left-hand side, and it gets half the difference between the smaller and the larger on the right-hand side. So it completely makes sense that the area of the trapezoid, this entire area right over here, should really just be the average. It should exactly be halfway between the areas of the smaller rectangle and the larger rectangle. So let's take the average of those two numbers. It's going to be 6 times 3 plus 2 times 3, all of that over 2. So when you think about an area of a trapezoid, you look at the two bases, the long base and the short base. Take the area of or multiply each of those times the height, and then you could take the average of them. Or you could also think of it as, this is the same thing as 6 plus 2, and I'm just factoring out a 3 here. 6 plus 2 times 3, and then all of that over 2, which is the same thing as, and I'm just writing it in different ways. These are all different ways to think about it. 6 plus 2 over 2, and then that times 3. So you could view it as the average of the smaller and larger rectangle. So you multiply each of the bases times the height and then take the average. You could view it as, well, let's just add up the two base lengths, multiply that times the height, and then divide by 2. Or you could say, hey, let's take the average of the two base lengths and multiply that by 3. And that gives you another interesting way to think about it. If you take the average of these two lengths, 6 plus 2 over 2 is 4. So that would be a width that looks something like, let me do this orange. A width of 4 would look something like this. A width of 4 would look something like that. And you're multiplying that times the height. Well, that would be a rectangle like this that is exactly halfway in between the areas of the small and the large rectangle. So these are all equivalent statements. Now let's actually just calculate it. So we can do any of these. 6 times 3 is 18. This is 18 plus 6 over 2. That is 24 over 2, or 12. You could also do it this way. 6 plus 2 is 8 times 3 is 24, divided by 2 is 12. 6 plus 2 divided by 2 is 4, times 3 is 12. Either way, the area of this trapezoid is 12 square units.
So using what we just learned about the area of a trapezoid, we know our base 1 is 4, our base 2 is 2. So we add base 1, add base 2, we divide that by 2, and then we multiply it times the height, which is 2. So the formula is base 1, add base 2, divided by 2, times height. So 4 add 2 is 6, divided by 2 is 3, times 2 is 6 units squared. Now this is all practice, so if you want to, you can continue on and do problem B, where you'll plot out the vertices, the coordinates for each of the 4 shapes, and then find the area if you want to. But what I want you to do is turn to page 62, and you'll see what is on the screen here. These are the things that I want you to find. I want you to find the missing coordinates. So if you look right here, there's the missing coordinate, there's a missing coordinate, there's a missing coordinate, and there's a missing coordinate. So find that missing coordinate, and then find the area for each shape. So the two things I want you to do, find the missing coordinate, find the area. I want you to pause right here, work on this, and when you think you've got all the answers, press play. So what you should have got for each one then, so for your rectangle, your missing coordinate is, oh, get that here. Missing coordinate is 4. For the right triangle, your missing coordinate is 10. For the rectangle, your missing coordinate is 12. And for the parallelogram, your missing coordinate is 14. For your areas, this rectangle would be, your base is 10 minus 4 is 6. And your height is 10 minus 6 is 4. So your area equals base times height, or length times width, equals 24 units squared. For the parallelogram, again, your base is 10 minus 4 is 6, and your height is 10 minus 6 is 4, so 24 units squared. For the triangle here, on the right, the right triangle, you've got 10 minus 4 is 6, you got 10 minus 6 is 4, so 24 divided by 2 equals 12 units squared. For the rectangle, you found 12, so you know 12 minus 6 is your base. And this one gets a little bit trickier because you're crossing the axis, but you know you've gone, there's 4 here, and then this goes down to -8, but it's 8, so 8 plus 4 is 12, so you've got 12 times 6 equals 72 units squared.